Hello everybody and welcome back to another one. This should be a quick video and it will be a bit of a technical exploration around how to work with the AP trampoline. So the problem is that we have a binary blob, or we are going to have a binary blob, and we need to have a way to have that binary blob imported into our kernel's binary so that we can copy it to our trampoline page. So that would be the problem we'll try to resolve through this one. So let's get started. I'm thinking here that we can go for, so here we should be in arc, and I think what I'm going to do is I'm going to create a trampoline folder here with a file AP, let's call it, let's call this for ASM, and then have this be trampoline .asm, sure. And here I'm just going to skip a few steps and I'm going to go to the BIOS, stage 2, I think. We have a start.asm here. Yeah, that looks okay. So let's actually just copy a few of these and go back to trampoline. Yep, good. Cool. So I'm just going to get rid of all of these and sure, I'm just going to leave this like so. Very nice. So actually I'm just going to remove this also. That should be okay. Let me do this and have magic 32 here be yeah, so let's do something like this. Okay, I'm just going to check that we have that use 32 here as well. We should have, yep, okay, that's fine. Very nice. Cool. So now that we have this, we are going to go into our build.zig. So everything we do should, in theory, be done in here. And since the trampoline stuff is architecture specific, we are going to actually try to put that on top of the architecture module that we built already, I think. Yeah, I think that should be okay. So here I'm just going to get the module here. Let's return here. And actually, I'm going to do something like arc specific build. Yeah, let's call it add arc specific steps. Sure. This here should take arc. It should take B, the build. Should take allocator, B, and module. Yeah, sure. Okay. So function add arc specific steps. This one here takes arc, which is a stud target CPU arc, and then it takes alloc, which is a stud mem allocator, and then it takes B, which is a pointer to stud build, and then it takes module, which is a pointer to stud build module. And this one should probably error or something. So what is the problem with this? Okay, so it needs a try here. Cool. Right, so here what I'm going to do is fairly simple. So I'm just going to, I'm just going to switch on arc. And for now, since we already only have one single architecture, whoops, I'm just going to do this. And yeah, sure, let's, whoops, arc, specific steps, sure. And then this here would take just alloc p and module. Yep, sounds pretty okay. And then this one here, yeah, sure, we just do else. Can just panic with unhandled architecture, sure. Right, so now here, function x86, specific steps, whatever that is, and then here we do alloc stdmem allocator, and then we do build is std build, and we do module, which is a pointer to std, whoops, build module. This also should probably just error, otherwise it just basically tacks stuff onto module, so that should be okay. What's the problem with this? Yeah, so this one needs a try here. Cool, very nice. So now that we are here, so first of all, let's build our binary blob. Yeah, I think that should be okay. So trampoline bin, and then this would be b.add system command. Yeah, okay. So this one should take a slice of strings or slices. I'm just going to use phasm because I know how it works. Input. No, wait. So no, phasm just takes files. Doesn't take any other things. So const or rather trampoline bin dot add file arg, and then here we need a lazy path to where our trampoline file is. Okay, so let's actually get this from here. Yeah, sure. So const trampoline path is b.path. Then here we take subpath, which should be that path, which is copied. Or rather, actually, let's call this trampoline path. Remove this, and here we should probably just replace this, as well as this, and this, with just, since we already know that this is x64, we're just going to do that exactly for now. That looks okay. So here, if we do b.path, trampoline path, should be happy about that. So what's the problem here? Yeah, unused parameters, that's fine. So let's actually use it. No, add, so what is this? What does embed path do? Include this. Not sure what this does. Might need to look it up in the Zig library, but for now, let's just actually let's not do anything here for now. Let's just build this file here. So we have the input, and then we need to set the output for this. So that would be trampoline. So let's call this assemble, assemble, and then this would be trampoline bin assemble dot add output file argument, and we want this argument to be trampoline dot bin. Sure. Now we want to attach this to module somehow. So let's call it I'm not sure how to do that though. So let's just try add embed path, I guess. I'm not sure what that does, but wait, hold on. Yeah, that should be okay. So now if we go ahead and just build this, I just want to see. So it does build, okay. So if I do find kernel zig cache, and then I just grep for trampoline. Okay, so we do have a trampoline.bin, and if I do xsd, just copy this here. Okay, and we do have our 4 bytes that we've put into our trampoline. Yeah, so F401 and F402. Those are our 4 bytes. Cool. So this first step works. Now we need a way to get this file here, this output here, and embed that into our so I'm thinking embed that into our arc module. So how do we go about that? I think we can in arc here. I think there is something we can do here. So if I go and create trampoline.zig here, and in this trampoline.zig I do something like const trampoline that data is embed file, and if I do something like trampoline, if I can create an anonymous import, so trampoline, same way we've created, so if I go anywhere here, same way we've created arc as an anonymous import, as well as options. This should probably work. So let me just take a look at how we've created those. So it should be around here. So add import. Yeah, we can use this add import, and it takes a module and gives us the import given that name. Okay. Fine. So let's try that actually. So module.add anonymous import. I think okay. So we give it a name and then we give it options. So the name would be trampoline, and then options would be oops. So let's put this here and let's try to see what options we have. So source, whoops. Source file, we don't really care about those. Imports. Actually, should we just give it source file trampoline.bin, trampoline bin? Does that work? Yeah, I don't know. So we can get rid of this now, I think. And if I rebuild this, okay. So it didn't complain, but not sure that it actually built what we wanted it to build. So hold on a minute. I'm just going to take a look at this. So trampoline.bin is cached. And I think what we need to do is we need to go ahead and use that import somewhere. So I'm just going to go to SMP and do const trampoline is at import. So it should be arc.trampoline. Oh, and did we not generate that? Or did not get generated? Yeah, I think it did not get generated. So zig build gen arc. Oh, yeah, actually, let me just do kernel zig cache to force that. And this should just regenerate the whole thing. There we go. Cool. So now if I go here, this should work. It does. And now with this, I think we can just go ahead and somewhere around here, can we log.info trampoline data is, and print that as a hex string, or rather just print it as a string. And here we can do trampoline data, and of course we need to make that public, don't we? I think we do. And this is where the problems should start. No. Okay. That's fascinating. Yeah, so the problem is we have no trampoline data. Okay, so what is going on here then? Right, so instead of doing this, I'm just going to create a new one and do LVM read elf, and just going to read build kernel.elf, and I need to see where is the trampoline being put. Right, so hold on, let me just do trampoline. And we have no trampoline, sadly. Right, so if we go back here, let me just redo the whoops. So let me just remove kernel the cache just to force a rebuild. Okay, so let's see what we did here. So run phasm trampoline is successful. But I don't see for the other things. Yeah, okay. So why is this not working? So output file argument, this returns the file, the path to the file. That's okay. It should be okay. Add anonymous import is also okay, I think. So what is the problem here? Here we are doing things on the module itself, which we are returning here. Okay. So I'm not sure what the problem is here. Actually, just going to try one other thing here before giving up, and that would be, so we know that this goes into arc, so let's just do arc. Okay, there's no arc specific things here. All right, so yeah, I feel like we don't have anything to do with the architecture stuff here, which is weird. Which is kind of weird. Okay, fine. So I'm just going to do find kernel zig cache, and then we grep for arc. Arcfile.zig. Not sure what arcfile.zig is, but okay. No, that's fine. No, okay. So let's try something else here. I'm just going to go to trampoline.zig, and I'm going to so how do we go about this? We want this to be a consuate with a link section of, let's call it trampoline. Okay, let's see if that does anything different. Actually, at this point, I'm just going to try something else. I'm just going to do this, trampoline2, and if I only get an error, then so what is the problem here? Yeah, okay, there we go. So file not found. Good. So that means that when we build this, it actually does something with trampoline. So let's just find grab trampoline. We just have the binary from that. And now if we actually take a look at the sections here, so hold on, let me just clear this first, and then we can read the elf again. So this time here, if we try to find a section called trampoline, do we have one of those? I don't think we do. I do not think we do. So actually, let's go here and we'll try something. We'll try to put in read only data. We try to put trampoline. Okay, so let's try this again. Right, so go up here, and it should be in read only data or something. Yeah, I'm not sure what's going on. All right, let's do something else. Then we go to smp.zeg, and instead of just printing this, we print something like this. And then here we can do a pointer to trampoline.trampoline data. Okay, let's see. So I'm just checking that this has been rebuilt. Yep, okay. Fine. So let me just rerun this. So it's a constituate at this address here, 83F888. Okay, and that means that, whoops, it means that we can go here, not read elf, we need to do obj dump. I think we should already have, yeah, so let me add a less onto that, and then here we need to find this address. Okay, so we have the address here. Except that there's absolutely nothing in there. What is going on here? What is this? Where's my file actually? Hold on, I'm just going to double check that the file actually still contains that. Okay. So what is going on? All right, I'm just going to try one last time to just rebuild this, just to make sure that everything is okay. All right, so did it rebuild it at the same? So kernel say cache, and we grep for trampoline. Yeah, so it just rebuilt it, the same file. That's fine. I'm just going to check that it actually rebuilt it. And it looks like it did. So the trampoline file looks okay, but for some reason it's not getting put onto the module. So not sure why. Okay, so if I go back here, what does this thing do actually? It returns a pointer. Okay, so it means that this here is wrong. And if I go to here, so let me just replace this with any. Sure. Okay. So does that mean that now this should print something more legible? Would you look at that? That looks not too bad. So hold on. any way we can get this to be, so I think there's should be some stud format, I guess. So let's type in hex and see. Was it maybe in mem? Okay. Bytes to hex. Yep, that sounds okay. So this one would be trampoline data, I guess. I'm not sure, but we'll see. Oops, rebuild that. So it needs a type, I think. So I guess, wait, no, it needs a case. So let's just do lower. Okay. So hopefully this time we actually get something. Oh, and we do. Okay, I'm actually surprised that we actually get something from this. So let's actually search for those. So F4 1C. Huh. Okay, so I'm not sure where this is coming from, but I guess it's something. So let's do this, and let's do trampoline. Trampoline data, and print that as a pointer. It should already be a pointer, so it should just work. Okay, so it's at this address. So let me just copy just the ending of that and just search for that. All right, so let's see here. Okay, so F4 1C, F4 2C. That looks pretty good. So it's been anonymized and put into there. Very nice. So now at least we know how to work with these. I just want to do a few things more. So trampoline, trampoline data.length. I just want to see if we are aware of the length of the thing. Might not be possible though. Oh, never mind. I think it was encoded in the type, but we'll see. Yep, it says it's 4, so it should be pretty good. So now let's push this one more notch. I'm just going to go here. Yeah, you know what? I can't really be bothered, so I'm just going to go to start.asm stage 2, and at the very bottom here we have some padding. I'm just going to copy that padding here, bump that to 32. Sure. Let's build this. I just want to see that this actually impacts the length and stuff like that. Ooh, that looks pretty good. So hold on. We have the value, we have 288, that's the length, and we have the pointer. Very, very nice. Well, that was pretty much it for this one. We have worked on some technical exploration on how to embed our trampoline code into our kernel code so that we can copy it to our trampoline page. As always, if you've liked this video, hit like, subscribe, tell me what you thought about it, and why not tell a friend. I'll see you next time. FLCNOS.